Probability is more than just guessing, it is the mathematical study of randomness. On standardized tests, success depends on choosing the right strategy to organize outcomes. Today, we will master tree diagrams and combination formulas to solve complex problems with ease. Every probability falls between 0 and 1. To find the probability of an event, we divide the number of favorable outcomes by the total number of possible outcomes. Keeping this fundamental ratio in mind is your first step toward accuracy. When should you use a tree diagram versus a formula? Use tree diagrams for multi-step events where order matters. Use combinations when you are selecting a group and the order of selection does not change the result. A tree diagram maps out every possible path in a multi-stage experiment. Each branch represents a choice or outcome. By tracing a path from start to finish, you can visualize the entire sample space without missing a single possibility. To find the probability of a specific sequence, multiply the probabilities along the branches. If you flip a coin twice, the chance of getting 2 heads is 1/2 times 1/2, resulting in a 1/4 probability for that specific path. When order is irrelevant, like picking a committee of 3 people from 10, we use the combination formula. This formula removes the redundant permutations, giving us the total number of unique groups possible from a larger set. The exclamation point represents a factorial, the product of an integer and all integers below it. Understanding factorials is essential for combinations because they help us quantify the total ways to arrange or select items within our set. Let's look at a tree diagram example. If you pick 2 marbles from a bag of 5 without replacement, the probabilities change after the first draw. Notice how the denominator drops from 5 to 4 on the second set of branches. By multiplying the branches for red and then red, we get 6/20. Always simplify your fractions on the test. 3/10 or 30% is our final answer. The tree diagram made this sequential dependency easy to track. Now for combinations. If we need to choose a 3-person team from 10 students, we use 10C3. Since it doesn't matter who is picked first, second, or third, the combination formula is our most efficient tool. Don't calculate large factorials fully. Write them out and cancel terms in the numerator and denominator. Here, 10 times 9 times 8 divided by 3 factorial simplifies quickly to 120. This saves time and reduces calculation errors during the exam. A pro tip for standardized tests: if a question asks for the probability of at least one event occurring, it is often easier to calculate the probability of none and subtract it from 1. This is called the complement rule. Always check if events are independent or dependent. If you put a card back in the deck, the probability stays the same. If you keep it, the total number of outcomes decreases. Tree diagrams are excellent for catching these subtle changes. To summarize, use tree diagrams for step-by-step processes and combinations for group selections where order is irrelevant. Identifying the type of problem within the first 10 seconds is the key to managing your testing time effectively. Remember these for pillars: multiply for paths, use combinations for groups, cancel terms to save time, and use the complement rule for complex at least scenarios. These strategies turn difficult probability questions into simple arithmetic. Let's try a quick practice. Using a tree diagram, calculate the probability of picking 2 blue marbles without replacement from a bag of 6. Think about how the denominator changes after the first blue marble is removed. The first draw is 4/6. The second draw is 3/5. Multiplying them gives 12/30, which simplifies to 2/5 or 40%. Great job mastering these probability strategies. This video was generated by Vision Solve AI.